All right, if you're into crypto, you know the big four, right? Hash rate, difficulty, effort, and luck. They're basically the engine of proof of work. But what if I told you that those same words are being redefined in a totally new, quantum inspired context? Well, today we're going to dive into that headfirst, and it all kicks off with one really powerful idea. Just think about this for a second. What if all that incredible energy and computing power that goes into securing blockchains wasn't just solving a random abstract puzzle? What if it was actually tackling some of the most complex problems in science and technology? This is the central question we're exploring, so keep it in the back of your mind as we go. And boom, here's the difference in a nutshell. Classic proof of work. It's a brute force lottery. It's like trying to open a lock by trying every single possible combination, as fast as you can. But quantum-inspired proof of work, or qPoW, is completely different. It's an optimization search. It's not about guessing wildly. It's about intelligently searching for the best solution to a real problem. Okay, so let's dig into the first and probably most famous term, hash rate. And we're going to see how this idea evolves from just being about raw speed to being about something much, much smarter, sophistication. You know the drill. In systems like Bitcoin, hash rate is just how many guesses your machine can make per second. That's it. More hashes mean more lottery tickets. It's a pure numbers game, all about raw, repetitive power. Simple. But in the PWA world, this is where we flip the script. The word hash rate still means attempts per second, but the key is that an attempt is a whole different ballgame. It's not a random guess anymore. It's a measure of the quality and the complexity of the work being done. So what is one of these attempts? Well, we're talking about some seriously heavy-duty computation here, things like tensor network contractions or running through quantum optimization cycles. Now, you don't need a PhD in quantum physics to get this. The main takeaway is that each attempt is a meaningful, valuable piece of scientific calculation. So hash rate here isn't measuring how fast you can guess, it's measuring the network's total throughput for useful quantum simulation. So, following that logic, if the work itself is way more sophisticated, it only makes sense that the puzzle, the difficulty, has to be smarter too, right? Again, let's look at the classic model. Difficulty is basically a numbers game. The network sets a target, think of it like a limbo bar, and miners just have to find a random number that's low enough to get under it. Higher difficulty just means the bar gets lower, making it harder to find a winning number. I love this comparison because it just nails the difference perfectly. Proof of work says, find any number smaller than this target. It's a simple yes or no question. But qPoW is asking something totally different. It's saying, give me an answer to this complex function, and make sure your answer is good enough. It's a shift from finding a lucky number to proving the quality of your work. So what does that mean in practice? Well, when the difficulty goes up in a qPoW system, it's not just making it harder to find an answer, it's demanding a better answer. The network might require a more precise calculation or for the problem to be explored more deeply. The difficulty itself is an intelligent dial that controls the quality of the work being done. And all of this brings us to our last two concepts, effort and luck. Because when you change the work and you change the puzzle, you completely change the rules of the game itself. Okay, so effort is basically how we keep score. It tells us if a miner got lucky or unlucky. In regular POW, it's simple. How many hashes did you do compared to the average? But in qPoW, it measures the solver workload. And this is super important because different miners might be using totally different methods to solve the problem. Effort is the concept that puts everyone on a level playing field, creating one fair metric for all that complex work. And then there's luck. In classic PoW, luck is just that. Pure, blind, random chance. It's a lottery. But in qPoW, luck is, well, it's more nuanced. It actually comes from the behavior of these advanced solvers. How they choose to explore the problem space can make them more or less likely to stumble upon a solution. Now, this is the part that is just so cool. It means that in a qPoW system, you can kind of make your own luck. A smarter, more efficient solver that intelligently aims at the most promising areas of the problem can actually improve its odds over time. The quality of your software, not just the speed of your hardware, starts to directly influence your success. It's more like being a skilled poker player than just pulling a slot machine lever. Okay, so let's pull all of this together now and really look at the big picture. We've taken 4 words that we all thought we knew, and we've seen how they've been completely transformed.
This chart really lays it all out. Hash rate goes from raw speed to valuable simulation throughput. Difficulty goes from a simple target number to a demand for high-quality answers. Effort becomes this universal yardstick for all kinds of complex work. And luck? Well, luck shifts from being pure chance to being something influenced by skill and strategy.
So the bottom line is this. We're moving from a brute force random search to an intelligent, optimization-heavy search that actually creates real computational value along the way. And the genius here is keeping that familiar vocabulary. It lets us use the same mental models, but now each of those terms points to a process that is just so much richer and more meaningful. And that really leaves us with this final big question to chew on. As we look to the future, what's going to define a secure and valuable blockchain? Is it just going to be about who can burn the most energy doing the most work? Or are we shifting to a future where we reward networks that do the most meaningful kind of work? That's the real question, isn't it? Something to think about. Thanks for joining me.